Hello guys, I am Silvio. Welcome to a new off-season mini tutorial. Whether you are a Christmas village builder, a diorama builder, or a model railway builder, at some point in your life you certainly found yourself wanting for your layout something that you can't find anywhere for sale, either new or used, obviously. This because anyone before ever thought of producing it. So the only thing you can do is try to build it yourself. Fortunately, these days, there are not only traditional and very time-consuming method of doing it, for example, using soft wood or styrofoam or thick cardboard. But there are also new technologies that can help. The problem is that almost everyone is very attached to those traditional and very time-consuming methods, and also very reluctant to update. With this mini tutorial, I would try to help you dispel any doubts you may have, because new technologies are very useful, more than very useful, especially when it comes to reducing the overall construction time. One of the most useful things that can bring life to your layouts are bridges. In the next few minutes, you will see how to build a bridge in two versions. The more traditional or old school, if you prefer, version that I will call the analog bridge, and the new version using new technologies and 3D printing that I will call the digital bridge. And also I will note exactly the time involved from design to painting the finished model for both versions. The starting point is certainly the sketch of your original idea. Whether you do it using a paper, a pencil, and a ruler, or using a computer with some technical drawing software, it is the same thing in theme of time. So, for my own convenience, I will use a computer. Well, guys, as I told you in the intro, I am here to sketch my idea of a bridge. And I will use this sketch for both the analog bridge and the digital bridge. I will use this software that is called Rhino 3D. I know what you are thinking. Okay, it will use a 3D modeling software, very complicated to follow. No, we are not here to teach you how to model, but to give you an idea of my bridge, the starting point of my bridge. Instead of using paper, pencil, and a ruler, I will use these to do it. And I will try to model a bridge as simple as possible, as quick as possible, trying to get a decent bridge, obviously. So let me start. Here we have the top, the front, the right, and the perspective that will help me see the bridge in 3D. And even if I will work on the side of the bridge mainly, let me work on the front side. And let's say that I want this bridge to be 24 centimeters long and 11 centimeters tall, like that. And this will be the side of the bridge, okay? The side. This is 11 centimeter and this is 24 centimeter. But also let me mark the mid here and let me mark at 10 and 9 centimeters. So 11, 10, 9 centimeters here some point, because I don't really like straight rectangular side of my bridge, and I will delete this rectangle. And obviously I will build a new one having always 24 centimeters in length, but instead it will go here, then touch here the middle, this one, and returning there. I will cancel those reference lines there. This is better, a better version of a side for a side, a wall for a bridge. But two squared corner there. So let me round the corners. Let me do a 3 centimeters rounded corner here, and this has become rounded, and then 1 centimeter corner there and there. You can see right now that it is more good looking having it with no squared corners. Let me hide this and let me do another rectangle, always having 24 centimeters in length, but only 8 centimeters there, 24, and there. And as I did before, let me mark the middle, and then let me mark there at 9 centimeters. So this time I will delete this one and I will go with 24 centimeters, 8 centimeters there. Instead of going straight, I will go up there at 9 centimeters. Then I will come down at 8 centimeters there, and then joining the point there. Okay, so right now you have this form here, this shape here, and this other shape, like it was a strange envelope for a letter. I made some round corners for the biggest one. This one I will leave it like that. Now I simply have 2 lines, guys, and it is very flat. As you can see here, it is very flat. So quickly, I will transform this in an idea of a bridge. Let me take this one, the tallest one, the taller, and let me give it a thickness. In 3D modeling software, giving a thickness is extruding something. And I will give it a thickness of 2 centimeters. Take a look here, it immediately resembles a wall of 2 centimeters thickness. For this other form here, this one in yellow, I will give it a thickness of 8 centimeters, like that. I will take this form here, and I will place it like that. Then I will not design another side wall for the opposite to place here on top or here on the other side. I will simply Ctrl C, Ctrl V it. So I copied and pasted it, and now I will move it there. Take a look right now at the model. It starts to be similar to a real bridge, with the two side walls there and the road in the middle. Not a flat road, but a road that goes up and then goes down. These for facilitating the humidity, the water, like it was used in old bridges. Just remember that this bridge is Victorian time bridge. And so the water, the rain that will drop on top of the road will be facilitated to flow away from the road. Okay? So this is a strange box, not a real bridge. So let me mark once again the middle there. And let me hide all the other forms you have here. Okay? All the other forms here, I will hide them. Okay? And let me do a circle starting from here, the middle, having a radius of 7 centimeters or a diameter of 14 centimeters, like that. Oh, guys, it is nothing else than a circle. But let me give it a thickness, a very big thickness there, like that. And let me move it like that. Magically, I will unhide everything, and you will see there that you have a strange form with a big cylinder under it. Let me do a strange thing. I will subtract the cylinder made from the circle from the other forms. So I will select this side here, and it becomes yellow. This other side, the road, yellow, and the other side wall. And I will tell the software to Boolean difference. It means subtract to those forms I modeled the cylinder. I confirm. Guess what? You obtained a bridge, guys. A bridge. Maybe you can already use it like this. Okay? If you want. But guess what? I don't want to use it like this. I can cancel at this point everything I will not use, okay? So I can hide those ones and cancel those ones. Unhide everything. I have a bridge like that. Let me mark once again here the middle there, like that. And let me do 2 arcs of a circle. Okay, I will hide everything. So now I have there. I take this command here that is the arc, and I will start this arc here. Okay, then I will get the same thing, but a little further, 1 centimeter more, like that. Okay? So now I have 2 arcs of a circle, like I don't know, a rainbow. Okay, like a rainbow. Let me do one thing. Let me take a line from this point here to this other point here. Then I will take this segment here, and I will duplicate it all along this arc here. So array, polar, from the center, 20 items, 360 and 180 degrees. Okay, Control Z. No, it's not like that. It is array from the center. It is 20 items and minus 180 degrees. So now I confirm, and guess what? You can already imagine what those are if you know bridges and arcs. But for being more useful, let me take those 2 arcs, they are their name in geometry, and let me split them using this line and this line. Okay? Right now, I will only need nothing more than these 4 segments here, so I will cancel everything else. I will remain with this, 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 and this. Okay? Good. Now I join everything together and I get only a form. Okay? One and simple, 1, 4. Let me mark 24 as before. And the middle. That is 12. There. So let me take this segment here and let me do as before, transform array polar. The center is always this 1. The number of segment is always 20 and minus 180 degrees. I got 1 more. I have 1 more, then I will eliminate. Let me eliminate this one and this one. Now I will group everything together. Maybe not. Maybe not yet. So right now I have nothing, that some segments there. But if I take every segment and I give them a thickness, let's say of 3 millimeters, so 0.3 centimeters, like that, okay, each and single one segment. And then let me group this, and then let me reappear everything else, and let me move this a little there. You can see that now you have a border that is represented by those stones there, creating an arc there. I will duplicate this arc here. Okay, another method. I mirror that. So I get the exact same thing from one side and from the other side. Okay. This is my idea of a bridge. Yes, no, yes. If you want, you can stop here and you have a decent bridge. Obviously, with the traditional methods, you will have to carve some patterns, and I will do it. Don't worry. But I would like to also add an end rail here. Okay? An end rail. An end rail. And I will start doing it, making a line of 6 centimeters like that. Then I will use this function and single points. It let me create a series of points there. Maybe I will do a lot of them. Okay, then I will fast forward for your convenience because I need to make a lot of points in strange ways. Okay, and maybe a last point. No, let's say it is more than enough. So I have the line before and I placed some points around or in the proximity of this line. And let me do a control point curve, starting from this point, going to this other, to this point, to this one, to this one, to this one. You can see that I'm no more drawing straight orthogonal lines, but I'm modeling something that goes from point to point and that has a strange form. For now, it has a strange form. To this point, to this point, to this point. Then I will go, no, to this point here, then to this one, then to this one. Okay, I have, so this strange profile here. Okay, let me take this strange profile here and let me do something that is called a revolving. I will turn this profile here that you see in yellow around this line here. Right now you can see only nothing there. Okay, a strange line like that. But if I take this curve here and I revolve it along this axis here, starting angle 0, revolution angle 360 degrees, and I confirm, here in the front view I obtain something that resembles a leg of a table milled with a mill, okay? But in reality I obtained this shape here. Okay, this shape here. let me continue, okay? You will understand where I want to get. Let me, oops, no, let me go down a little, maybe reaching, maybe having this horizontal line near touching here, like that, okay? Let me draw a straight line from this point here to this point here. And let me take this form here, this strange pole there, and let me transform it array along a curve. No. Let me take this one and place it like this. Okay, better, like that. The starting point. And repeat array along a curve. I select the curve and the number of items, 7 items. Okay, 1, 2, 3, 4, 5, 6, 7. I don't need any more those one here. I will cancel them. Let me move this one there, this one here, always having this line here touching the top border of the side wall. Like that. I will go down. This one is good, this one is good, and instead of moving those 3 ones, I will do something more intelligent. I will mirror those 3 ones. Like that. Okay, so now I will take all the 7 poles and I will move them in the middle there. Okay, perspective like that. Okay, the wall, the bridge and the vertical poles having those strange form here. I'm not quite finished, but almost. So let me do a line going from let's say the third horizontal line 1, 2, 3 to the third horizontal line there 1, 2, 3 to the third 1, 2, 3 to the third 1, 2, 3. Okay, then let me do 1, 2, 3, 4, 5. Let me do another line going from 1, 2, 3, 4 from the 5th horizontal line above the other one to the 5th there, to the 5th there, to the 5th there. Okay, I have two lines. I have this line here and this line here. Okay, in line with the vertical poles. Now I will take this line here and I will build around it. I will use it as a center for a pipe. A pipe that has a radius of 1 millimeter, so 0.1 centimeters, and the radius the same thing, 0.1. Okay, and I will do the same thing for this one. Voila. In the model you have this thing here. Now guess what? I will take those two pipes there and I will mirror them along the middle. Like that. So now I have the poles, vertical poles, and some horizontal, not very horizontal, but inclined cables or smaller poles there. I will move them in the middle, like that, and you obtain something like this. Okay, then another thing, as I always do, I will mirror them once again, but this time using this middle here. Okay, ta-da! I made a almost decent bridge. If you want to know precisely, it is 24 centimeters in real life. Okay, and to the top there, (11 centimeters). Okay, like that, and you have the same thing here. So 11 centimeters, 24. Those are the end rails, and those are 4 centimeters. Generally, the distance between this point here and this point here is around 4 centimeters. Okay, a little more than 4 centimeters. No, so they are not that exaggerated. Okay, this is my bridge. Final version. No final version for the analog version, because I will have to carve in the material the pattern, some pattern for the road and the side walls, but it is not the final overcome for the digital bridge. Okay, let me cancel those one and let me get these exported, everything exported as an STL file. The STL files are used as reference for 3D printing. Okay, stereolithographic files, and I will get the name, I don't know, bridge AA1. Okay. So now you have the idea. I spent a lot of time speaking to you, guiding to you. So let's say right now I am at 33 minutes of modeling. Let's say 20 minutes. Okay, let's count these as 20 minutes of modeling time for getting at least the analog bridge. Okay, the analog bridge like that. So now only for the digital bridge I have to make some stones and some patterns on the road and on the side walls, and I am using this other software that is called ZBrush. As you can see right here, you have the bridge that I've just modeled. Okay, I will not do it entirely. I will show you the beginning, then I will show you the final result, simply because it will take at least another 20 minutes. Okay, so now I have this. Let me mask what I don't need to do a pattern onto it, like this. Okay, like this, and then I will also mask this side here. Let me use my pen and my graphic table. It is better, more precise than my mouse, like that. You can see it is more precise like that. And then I will eliminate what I went through too much, like this. Then I will go to the light box here, and then I will go to a set of a brush. Here I am on the brush, and I will go to the wall maker. I will go to drag and drop, and I will choose the pattern, let's say 26, no, 29. I've chosen this pattern. Then I will also have to make the pattern there. So I will, so the clear zones are where the pattern will be applied. The dark zone are where the pattern will not be applied. I'm doing a deepness of 30, and I'm, let's say, 150 as dimension for the pattern. Then I will start here, and I will drag it down a little, like that. I will continue here, like that, and then like here, and then you see how simple it is to get a wall, a pattern wall in this case. Okay, and same thing again all along there. And if I show you here, it is flat, here it has some difference in depth. Okay, I will do the same thing on the other side, and instead for the road, okay, for the road, let me reduce this and let me mark this for the road. So dark will never, zone in dark won't be affected. Okay, maybe not like that, but maybe like that, and like that. So the road will be only in the middle. Let me choose another, maybe not a wall, but this time a wall. Not this one. But this one. Let me choose a pattern. A squared pattern. Maybe this one. Okay, let me take a look of what I will get. Yes. Maybe like this one. Intensity always 30 like that. And then I will go not that much, maybe 50%. I'm trying there. I'm trying. Yes, better. Okay, let me do maybe at 200. I need to cover maybe 250. Yes, like that. I will mask here and I will continue here like that. And you can see that no, Control Z, maybe I went a little too much like that. Okay, like that. So I get a pattern even on the road. Let me finish the road and then also the wall there, and I will let you see the final result. Okay, so guys, this is the final result. As you can see, I didn't made any pattern here on this side here and on the other side because this will be joined by some roots. I made the same wall here under the arc there and then a different type of pattern here on the side arc there, okay? On the side arc there. So I get, and obviously on the road I get another pattern on the road that is like that. So now the bridge is pattern and you can see that the side is not completely flat and the stones are not at the same level. Some are protruding more, some are protruding less. So 25 minutes to get this result here. 20 and 25 minutes equal 20 minutes for the analog bridge, 25 minutes for the digital bridge, and plus 45 minutes of design for the digital bridge. Let's start building something. Now guys, guess what? We will continue talking about the bridge, but this time the analog version of the bridge. If you prefer the standard way of building it, the old-fashioned way of building it, the normal way of building it, not too modern, not using nowadays technologies. I will use materials that can be found everywhere in, I don't know, in stores, in hardware stores, in Home Depot, Leroy Merlin, Brico's, etc. all over the Europe and all over the US. And I will only calculate the time I will spend to effectively build it. So I will not take in consideration the time I spent getting the raw materials. For the digital bridge, I haven't calculated the time I had to spend to get the filament I've used. Here, I will not calculate the time I spent to procure these raw materials here, and I will explain right now what are those materials. Here I have a couple of arcs made with this same material. This is a panel, not entirely panel, a piece of a panel having a thickness of 4 millimeters, okay? And it is extruded styrofoam panel. More specifically, this is used as insulation in the walls. Very thin, but especially used behind some very thin walls. It has a face with some little skin. I will not use that. And the other one is pure and simple extruded styrofoam. I will not talk about the difference between extruded and expanded styrofoam, as this is expanded and extruded, because I made a video about it some last season, I think. Maybe I will link it right now there. And so this is extruded styrofoam, and here I have the standard expanded styrofoam, or EPS styrofoam. This is XPS styrofoam, and here I have two versions, the blue one and the yellow one. The yellow one is once again some extruded styrofoam panel. It is a piece of an extruded styrofoam panel. It has a dimension of 24 centimeters by 13 centimeters by 2 centimeters in thickness. The blue one is the same, but the blue one is a middle in between the white and the yellow. Pure expanded, high density expanded styrofoam, extruded styrofoam. Less dense, middle dense, more dense. They are not equivalent, guys. If you have already used this kind of foam panels, the expanded is not suited if you have to carve into it, I don't know, some cobblestones, okay, or some tiles or something like that, because it will lose pieces and I will have to carve something on the bridge. And this is well suited. I will try make a quick experiment if it is suitable, this high density styrofoam panel. Styrofoam, expanded styrofoam panel. You have seen in the very beginning of this mini tutorial how I started with the model of the bridge, and I will try to get a decent bridge. This is only for me, guys. I really want to demonstrate that yes, I use 3D printers, but I still can build something with my bare hands using standard materials. The design, okay, I would have to design the bridge for the digital version and also for the the analog version of the bridge. Okay, so I will record exactly the time I will spend on the building of this analog bridge. Okay, and I will get a timer. Okay, I will place it reset. Let's use a stopwatch. Okay, let's use a stopwatch. It will start. Okay, and then I will reset it. Each time I will make a pause because I will not be able to build it in one session, and I will go from there. Okay, these will be for both the version stone bridge, mix between old stone bridge and the Victorian time bridge. I'm using it for my Christmas village for this 2026 new season. That will be new season. I am still in the pre-season, but it can also be built for dioramas, train scale models, etc. Okay, it is a way of doing it. Let me start. Click, and you will have a look at the clock. I think I don't know where I need to place it. Maybe I will place it there. Are you still able? No. I will place it in the other way like this. You will not be able to see it. Let me do some space, placing it there. Yes, it will be good like that. So I will start by not cutting anything, by doing some stones. I will start briefly with the extruded version. I will do stones that are, and I will change my glasses for a better view, 2 centimeters by 1 centimeters. So let me mark this each 1 centimeter from this side. 1, 2, 3, 4, 5, 6, 7. And no, I'm not broke. I'm using a lapis because I don't like long pencils. They are not perfectly usable with my hands. When I sketch something or do such works, I prefer having some lapis and use some lapis. Then the horizontal lines like that. And you can easily see that with the extruded panel, the grooves are immediately visible like that. You see how straight and how easily are the grooves to have there. This is the starting point for the stones that we have. Let me try to do the same thing with the high density expanded styrofoam. I already know that it isn't suitable for this one. Let me do the same thing. Okay, usable, doable, but less effective. But I think I could have used also this one that is cheaper. Let me continue on the good one, and let me restart the TikToking. First one, I will pause because I will try to see the effect even there. With a minimum effort here, the stones, the bricks, are very well defined. Here, no, I should have applied much more force. You see, too much materials come out, I lose the form here. I'm losing a big piece, a big choke there. This will mean that I will have to work some more hours to try to repair. I know that many of you do cobblestones like that, walls with this type of material, the expanded styrofoam. Maybe this is because this is the European way of making them. Maybe you get more stable styrofoam in the US or in other countries, in Australia, but I tend not to appreciate the expanded styrofoam to make such thing. When I have to design something, a cobblestone street, a cobblestone wall, or a stone wall, or a pebble wall, I don't like this material. I don't like it, guys. Sorry, but I will continue with this one.
Okay guys, starting point was like this one. Now I have a first phase of the wall. Let's stop. Half an hour guys, 30 minutes 41 seconds to get there. Obviously I will need also the other one, so I will do it. Maybe I will start the clock, but I will do a fast forward, okay? Because I will use the same technique to get a similar side, and I will let you see something. This will be my bridge, okay? From one side and from the other side. Not like that, guys. A bridge without an arc is not a bridge, guys. So, otherwise it is a simple wall. So, let me do this, check, and then I will start, and then I will fast forward once I will have finished it. Okay, so let's go. Okay guys, I will stop here. So 50 minutes. I didn't spoke during the second wall, so it took me 10 minutes less. And you can see that they modeling them or craving them in this way. You can have also walls made like that, and you will have continuity like that, vertically and horizontally. You will have continuity, okay? Maybe not vertically because here are not aligned, but once against the other horizontally you will have continuity, okay? Now let's continue, and let me do, before working on something else or on these two pieces, it is said that I will not use the high density expanded styrofoam pieces. Okay, my bridge is only 11 centimeters tall. This is 13 centimeters, and it is 24, so let me do 24, but at 11 centimeters, so it is 2 rows there. Let me mark the middle there. It is here, in this point here, at 12 centimeters. Okay, and let me do the same thing here. 24, 12 centimeters is there in this point here. Okay, let me take here the circle maker, the compass, the circle maker, and let me open these at 7 centimeters of radius, like that, 7 centimeters. Let me block this. I needed to do a precise work, so let me fix this. Nope. Okay, let me block this at there And let me do the arc. You can understand that I need 11 centimeters. If I add this panel at 11 centimeters, it would have been difficult to do. Then it is better like that because the pieces will be good. I take my X-Acto knife with a blade of 2 centimeters, hoping that it will be enough there, and very carefully, not exaggerating with the pressure, oops. So I will add 5 minutes, okay? Sorry guys, I had to check the camera there. Restart guys. So let me continue marking something. The middle here is as always 12. Okay. Let me go at 9 from the top. From the 11, let me go here, 9, like that. That is here, and from the 11, there. Let me go there. Okay, guys? Okay, now let me get serious with the cutting there. Big blade this time. Okay, same thing from this side here, guys. It is more natural now, the profile of the bridge, guys. Like that. I will made some sandpaper. I will sand it, not now, not right now. Let me cut at 11 because this is 11. I still remember you that this is 11. So I will go like this. Okay, and ta-da! Okay guys, so very little sanding required, very little sanding Let me do it very quickly. With the extruded styrofoam, using sandpaper, it is possible. Okay, I will not do this right now, because it is not the intent. I will stop this first section once I've done the same thing to the other. But you can observe that now you can imagine placing this. Those will be one side, the other side. In the middle you will have the road, guys. I still need to make the road in a particular way. Then I also need to do the under bridge. Okay, road, under bridge, under the arc. This will be like this. Use it under this, not like that, otherwise I will break it. 4 millimeters it is. I will discuss of that lately. So I've spent a little more. Let me do the exact same thing here. Let me do the exact same thing for this one. Then I will stop the watch. Okay, guys? Okay, guys. 1 and 1, 2. I will get sandpaper. Okay, guys. Some sandpaper to use there. I will start with some decent grain there. Restart. I restarted. So and now with a little piece of this sandpaper that is more smooth. Okay. I will add some more stones here, but not now, not now. It's only the upper side that is important, because here I will have something else. Okay, before getting to the road there and to the under of the bridge, I will make a pause, guys. They are the same height. Yes, the same height. The same shape. Not this one, this one. Like that, guys. Okay, this is the starting point. I will stop here. I will add 5 minutes. It has been 1 hour, 11 minutes of work. Okay, let me take a piece of paper. Voila, so let me mark. Let's call this like that. Analog bridge. Then first 1 hour 11 and 42 plus 5, 1 hour, let's say, no, correct, 16 and 42. Okay, so this is first one. I will add each time I make some more. Okay, I will get off this one. Okay, and I will go off. A pause. Then I will go with this before gluing them together. And then, already done? No, the most difficult part will come later for the end rails. The end rails will be very complicated. So guys, see you for something more about the analog bridge. Now guys, I stopped at this point. Now it is time for step number 2 of the construction of this analog bridge, or standard way of building it, or normal way, not digital bridge. This is the analog bridge. I was there, not completed, but before I needed to do some more steps. Let me work on this piece of extruded styrofoam here. It is very thin. It is 4 millimeter thick, and the the dark face, the dark gray face, is the face I will work on, because here I have these little skin that it is useful for some, but not for working. But anyway, I will use this only in one direction. One direction? Ooh la la. Okay, so this will be the under bridge like that, and I will do the same pattern. It will be a little more difficult here because I'm working on something that is very, very dark. Okay, I think it can be enough like that. Now, this will go very carefully because, as I already told you, I don't want this to crack, and hopefully it will not crack. Just hopefully, yes, it will go like that. Okay, I will glue this with this polystyrene foam glue. If I use some super glue, it will melt. If I use a PVA glue, white glue or PVA glue, it will take ages to cure. This is especially formulated for styrofoam. Extruded, expanded, so XPS, EPS, no matter, they will do. And it is a very dense and a gel practically, okay? It is a gel. I will approach the camera. It is a gel, not transparent right now, but when it will cure, it will become transparent, and you see as I move it that is very a gel, practically a gel. I forgot some pins. I will stop, I will get the pins. Okay, I got some pins there. I will use some pins. Okay, like that. Let me restart the clock and let me start by getting this glue there. Okay, it is very dense and it will not drip off there because it has to be like that. I will add a good amount. Like that. Then once again I will start from one side and go at the edge there. Let me pin this there. Okay, I will correct this lately. Let me it needs to start curing. Okay, so this is the general. Now the road there. So this, I think it will be more than enough to go from the side there. Half an hour. Okay, let's continue. Let me remove this. It is a mess. That glue tends to make a mess. Let me clean. Okay, so I was saying this will go there from one side, the other, and if I calculated correctly, I will add this there. Okay, it is a little, just a little bended, okay guys? Okay. You see that it is bended because I will approach the camera. Maybe you can see that the straight line is here, continuing here. The other straight line, it is continuing to go there. This is the middle, the top point, and here. Sorry guys, maybe I will go like that. You will see that from. Okay, so there is a straight line that goes from this point here to this point here. This is the middle on the line, and on this point here, the road is under this point, so it is bended. Same thing here, at this point the road is under, but in the middle the road is at the same level of the point, and here you have the straight line. Same thing from the other side. Okay guys, you can see that the middle is here, the point is here, the other point is here, and it is under. Okay, so it is bended a little, not too much, but it will allow the water to go away. Let me add some. This one is cured. Then I will remove those pins there. Oops. I will work on those leaders. I will let you see from this side. There are some arcs. 1 hour, 6 minutes. Okay. Those arcs are lower part 7 centimeters in radius as the border there, but they have also an outer radius of 8 centimeters. These will cover there, like in real life there are, but I need those to be worked on because they are made from stones there, okay? Okay, like that. Now guess what? I think the glue there, it is good. I will start by removing those ones because they are preventing me for getting there. And what is there? There is also this one. Let me start from this side. I will need some more glue. So one side the arc covered, like in real life, the support for the arc will protrude a little from the bridge, here too. Then the road with a different pattern, a little damaged. And what else there? Nothing else, guys. I could have finished like this, guys, before painting, but instead next will be adding handrail, as you have seen while I was modeling this, but this now is starting to look more like a bridge. Okay guys, it is starting to look a little more like a bridge, okay, from each side. I will stop there. 1 hour and 43. I will get my paper. So here I am. So second step, 1 hour 43 minutes and 8 seconds. I do the zeros like that. Okay, this is second step. Next one will be one long step to add the railing here. Well guys, I was at this point here with the analog bridge a few hours later. If you want at this stage, you can leave it like that and go with the priming and the painting, because you have the road, the bridge road there, and you have 2 centimeters of protection walls along each side of the wall. Not very tall in the beginning, so not very protective, again you risk to go, but in the middle, yes, you have. And if you want, you can leave like that. I have designed it like this to be used with some handrails. So maybe you want to paint, etc., go with the priming. I want to add an end rail, as you have seen during the first minutes of this, let's call it mini tutorial, when I was modeling it. And that railing is the real problem, guys, right now. Because, why? Because, let me change my glasses. Okay. I've duplicated here on some paper and the front view of the handrail, and this profile will go up here and up here. The problem, I modeled this in order to have it, yes, I know, a digital bridge. So modeled it and then sliced it and then use it for with the 3D printer to get everything together in just one piece. So my real problem are the vertical poles of the handrail. Okay, maybe the top is replicable, duplicable, but this profile here with the standard materials, I should have used some maybe some wood and then carved in the wood to replicate this. No, too long. I needed to prepare 7 multiplied by 2, 14 vertical pole like that. I will spend a week only on producing the pole. So I will need to adapt. Okay. For the horizontal part, I can adapt because they are simple some cylinder, long cylinder. I have multiple materials, multiple solution. The quickest one, you will see that the quickest one it is. So I modeled those vertical poles there, or pylons, no, but they are the poles, to be maximum 4 millimeters in diameter, more or less. Let me measure the largest part. It is 6, okay, 6, 7 millimeters, and the length, excluding the top, it is 4 centimeters. I need to find some replacement for these poles. I had to find, because guess what? I have already found them. So I will adapt the top, another solution of the material. I will try to use just materials that you can find on any hardware store or big shop like that. I don't know, Home Depot, etc. Leroy Merlin, as I already told you, sorry. Brico Center, etc. It is like that. So I will need to find the two materials to replicate that. My quickest solution, yes, it would have been skewers, but 4 millimeters in diameter skewers who are to find. Maybe 3, yes, not 4, and they tend to bend. If I don't need to have perfectly not bendable on the horizontal or on the inclined horizontal parts, I need something very stiff, very steady for the vertical part. So guys, I have found this. Those are pieces of uh, of so, stuff, of the rounded piece of copper. Okay, they use copper like that. It is not bendable. I had to cut this with some power tool. Okay, no, I don't count this because for me this is of working time, but here I have 1 hour of working time. I will not count it because it is raw material. As I don't count the time I spent ordering the filament for the 3D printer, then unpacking it, etc. Those are raw materials. Yes, also the time you spend to find the panels, etc., to buy the panels. No, I'm simply calculating construction time, building time. So those rods, not stuff, guys, sorry, rods, copper rods, ROD rod, and they are 4 millimeters in diameter. Very unbendable like that. Those rods come in 20 or 30 centimeters length. I sectioned them to be 4 millimeter in diameter, yes, but also 4 centimeters in length. Okay, like that, more or less, yes, like that. Okay, okay, and so on, like this, and like that, and like that, and like that. Okay, and whoops, and like that. Okay, I will try to use this at the starting point to build the this handrail that is not flat, it is inclined. Okay, what will I use for the horizontal? The horizontal that are, if I am correct, around 2 millimeters. Guess what? You have already seen them a few times around because I use them quickly. I will use those skewers for cooking skewers, okay? Because guess what? And there is also written there, they are 2.2 millimeters in diameter. Cheap as anything. I think this is 80 skewers, around one USD, 1 euros, okay, around that. And they are perfect to be placed like that, not in one single piece, but in multiple pieces. And as you have already seen, this will be hell to do because they tend to skip away. But, and I will use super glue. I will use super glue to connect them. So I will have to cut those. I will have to cut those. I'm not starting the clock because I just need to show you what I will have to eliminate there, the top, because it is it has some design on top, and then I will eliminate a part of the tip like that, voila, like that, because I need some pieces that are that have a constant diameter. Okay, so I will use that. Let me get rid of those, and obviously I have prepared 14 of those pieces of copper rod. And then I will cut each piece like that, insert in the middle, cut, glue them together. The problem, as you can imagine, oh yes, I could have used also copper rod, 2 millimeters in diameter copper rod for the horizontal part, but they are not cheap, the copper rod, okay? Not even the steel or iron rod are cheap, but I need them to be regular for the vertical. But then copper with copper super glue it's not 100% effective each time with metal against metal, especially with some copper or some iron that tends to oxidate, okay, to become green. If you leave the copper around, it oxidated, so that oxidation prevent to metal, even with the super glue, to get a stick together, to get glued together, to be fixed together. But if you mix materials like wood, bamboo wood or simple wood and metal, you can get a different result, okay? Last thing before starting, I need something perfectly that will help me getting everything there, okay, not moving while I'm gluing each piece together. Cut the other pieces and glue each pieces together, okay? So my solution would be double-sided tape. I'm already hearing you. Double-sided tape is not transparent and will prevent you from seeing what you have under. Yes, guys, but this double-sided tape is not white. It is very thin and very transparent, okay? And very transparent. And you will see, let me make a test for you, okay? Let me make a test. I'm not working right now, so clock. I place it like that, okay? It is white, I know, but once I remove the other side, you can see through. Here it is white with white, so you can't see through, but this become almost transparent, so I can see through the double-sided tape, positioning correctly and single one of the piece of copper rod where I need them to be. Okay, so this is the process I will be using. Guess what? Let's start. And the last one, guys, the last one for this first side. Don't push it too much. The problem is that you need to pay attention that once you have placed the top ones, the other don't push the vertical parts away. Everything needs to be joined together, okay? Like that, okay guys? Almost regular there. 22 minutes, guys. I hope you can see, yes, 22 minutes 30 seconds. Now for the glue, I will not pour the glue on top, no, never. Use small amounts. I'm using this super glue that is gel super glue. It will not drip everywhere, okay? And guess what? I will use once again a skewer like that, and I will add the super glue that will not drip off because it is a gel. It is the same super glue I use for joining together the 3D printed pieces, and is very effective. Now, activator. Like that, and it should have already cured. Yes, hard cured. Okay. Maybe I will use also from the other side, okay? It all depends on the stability this has. So let me test the stability of the structure. Yes, as you can see, it is stable. Before getting another glue, let me test this. Why not, guys? Okay, it's far from being completed, but look at the side there, okay, like that. Then I will test with some figurines on top of the bridge. So for better not so the super glue is from this side, let me have also super glue from this other side, okay? Okay, and that's what, even from this side, some activator. Like that. Yes, more stable, much more stable. It isn't bendable, okay guys? It is a single piece, very stable, okay, like that. I will, the other points are good, yes. Now, guess what? I will not do the second one, 36 minutes. I will try to find a solution for the top there. Not as beautifully modeled as this one. Here I have some hobby micro foam balls, different measure, different dimensions, different diameters. This one is, oh, it is 10 millimeters, no, maybe too much, 10 millimeters. This one 8 millimeters. Let's test with 8 millimeters. I've used those some 3-4 times during the years to make some something, I think, some top of some bridges already 5 years ago, no, 4 years ago maybe. So let me open this. Let me take one, and no, this is between foam and cotton, okay? It is not specified there. It cotton balls, yes, cotton balls, and very useful. The problem, or the advantage, let me approach the camera, is that they already have a hole here on top on one side, and the problem is that this hole, it's not perfectly dimensioned, it is too small, okay, to get there. So let me try to enlarge it. I certainly will be more noisy with our tool, but let me test if it works. Too quick. Like this. If it works. Yes, it can work. Let me fast forward. I will produce some more of them. Those are 10s too big. Those are 8s or 6, 8 millimeters. Okay. I will destroy the ball. Okay. So now the problem. I don't know if the super glue is good with the cotton, because it tends to absorb, the cotton tends to absorb very quickly the glue. So I really don't know if I should use this glue or the same I used to assemble the bridge. Let me try with this super glue. Sorry guys, I was saying I will not place the super glue inside the ball because I fear that it will absorb it quickly, but let me do it like that. More super glue tip here. Cleaning. like that. The other ones are glued here, no problem, and these will be placed there. Okay, will be placed there. Let me do it quickly. I will place it there. No, not right now, because yes. Let me mark something before. Let me measure. It is intended to be 1 centimeter. Okay, 9 millimeters. Let me mark this before getting the other done. I will mark the depth, this, so 9 millimeters will go into the bridge, okay, in order to maintain this correct. I will not use super glue in that case, because it will melt the styrofoam. Okay, let me just mark where I have to place the holes. So and I will use the glue together at the end, because you have seen how quick is the glue used there. I will do the holes right now here. This one needs to be enlarged a little more. Okay, it will be more than enough. At, let's say, 1 hour and 7 minutes before getting it completely done, and obviously before priming, I will need to make the second one. All right, 1 hour 54 minutes. This one goes here, so let me start with this one. Okay. Yes. Now, some glue, the same I used to assemble the bridge. Here we go. Here we go, out, like this. Okay. 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 Okay, I think. Let me stop the clock. Okay. So I will approach the camera, and if you want, I will try to get as vertical as horizontal as possible. I think that even the vertical poles, I'm not perfectly in line, but like that it is flat. And if I watch them each by one, they are aligned, almost there. So guys, building time, yes, this time it was the longest one, 2 hours for the handrails. What else, guys? Priming and painting, obviously. I promised you something. Let me get one figurine. Okay, I will use Mac from 2 seasons ago, okay? And even here at the H, okay, minimum at the elbow, the handrails, okay, but the figurine is visible, guys. But the figurine is visible, everyone is protected. And no, you thought I will reveal my new companion for the upcoming season. No, I will not. Mac stands there, okay, practically can goes everywhere. Priming and painting. I will not take time for the priming for this one and the other one, because with the airbrush it is simply 30 seconds. So 1 minute total for priming this. That's it, guys. Let's add to this. So third step, 2 hours 1 minute 14 seconds. Okay, 2, 3, 4, 5 hours. I am over 5 hours right now to make this bridge here. Okay, and it is far from being finished, completed. Well, guys, this is the digital bridge that just came out from the 3D printer. Pure and simple. I just left the supports there in order to let you see what means then cleaning something that comes out from a 3D printer, a filament 3D printer. Okay? So this took 17 hours to 3D print. 17 hours that I used to do something else. I've not stared for 17 hours in front of the 3D printer. I used those 17 hours to do something else. So these took 17 hours, but not 17 hours of my working time. It works lonely. It is one of the biggest models you can get in a single piece from a 3D printer in terms of width and length. This has a length of 24 centimeters and a depth of 12 centimeters. Just remember that the standard 3D printer bed, BED bed, not BAD but BED bed, it is 26 centimeters by 26 centimeters, so like that, from here to there. So in terms of one piece, it is at the limit, okay? not in depth, because it is a little less than half, and not even in 8 because this is 14.5 centimeters tall, and the printer can print generally 26 by 26 by 26. Last generation 3D printers I'm talking. Before was 22 to 25 centimeters. Nowadays they are 26 by 26 by 26, a cube of 26 centimeters. And I used the minimum possible support. I should have placed some more supports for the handrails there, here and there, but I didn't want it. I wanted to test if it will be possible to print this with the minimum effort possible and the minimum of use of material. Obviously, there the arc needed some supports because otherwise the 3D printer would have print in plein air and the filaments would have made a mess. This is pure technique, and don't worry, I didn't model those support, those 3 supports. It is the 3D printer, the slicer that I used to prepare the file I modeled for the 3D printer that takes in charge to add those supports in order to get a decent 3D print. So 17 hours. These obviously need some cleaning now, especially where I haven't used some support. Then these will go to priming and painting. The not digital, the analog or analogic bridge will not need priming, but this yes, otherwise the acrylic paint will not stick to the plastic, because this is plastic. Oh, it's not plastic like I'm polluting the earth. This is PLA plastic. It is polylactic acid plastic. It is a green plastic. It is made from non-edible corn. Okay, from corn, non-edible. I'm not wasting food. It is non-edible corn. The same corn used for making biodegradable plastic bags. But I'm not polluting, I'm not wasting food, and this is not plastic from oil, but from non-edible corn. It means it is a corn that humans cannot eat. Okay? Now I will go with the cleaning process. I need just to remove the supports because a bridge with the supports doesn't exist. And this is under the bridge, so no. Notice that I made these using, and you should already have seen it during the process, that I used in ZBrush some ZBrush, one of my 3D modeling software, to apply some brushes on top of the flat surface that I modeled in the beginning to obtain some rocks or some cobblestones, irregular cobblestones. Maybe I can approach the camera like that, and you see that they are irregular there. So not a flat surface. Remember, I'm talking about flat, so this is up, down, up, down, up, down, like real cobblestone or real pieces of stones. And even the arc here is not regular. I placed some of them more deep, some of them more on the surface, and I added some stone, different stone brush on top of them. Here no, because I needed this to be flat. Then I applied a different type of brush there. I have not modeled each and single one of those pieces of stone, etc. But it is the brush, a general brush, as you have seen. Even those are not singularly modeled and then applied. I used a 3D brush on a ZBrush. So guys, generally I wait around 6-7 days to paint my buildings, my figurines, after having primed them. I can't wait because I'm already behind the schedule for next season. So it is just 24 hours later. No, it is 30 hours later, but let's consider a day after, okay? And the analog bridge primed look like this. It is completely dried, okay, no problem. I didn't realize when I bought this glue here that I used to connect the foam parts together, and it isn't stated because I searched for it, but it isn't stated, that this glue has a percentage of coke, a crystal clear coke, okay, CAULK, coke, the same that you use to seal some groove that you need to seal your water tank, your fish water tank. And how I realized it? Because coke is not paintable. And I realized that, especially here, guys, where I added a little bit more of that glue outside, and when I try to prime it, the primer doesn't stick on some coke, and nor the acrylic painting, acrylic colors. You need some special colors to paint over coke. And someone may also say that it is impossible, but I have demonstrated it in 2022 that the coke is paintable with the right color, the right pigment. Okay, so in certain points the primer didn't stick onto the model, okay, but I will try to mask everything with the painting. Guess what, guys? First time ever you will see the the analog bridge and the digital bridge together, primed, okay, and this is the result. Maybe I can show you from the side also, like that, maybe, okay, like that. Hope that you can see everything. You have a certain differences between them. This one it hasn't been carved but 3D printed. You don't have precise grooves inside. Yes, here, there, in the pattern, yes. But otherwise, the primer is regular, okay? Side. Here it is more flat, guys. This technique is more flat. Let's say it is more detailed. The wall there, it is more detailed, even if it isn't defined yet, because it needs some black wash. Also the under, but it won't be visible. similar, yes, but not perfect. Here, more 3D effect. Sorry for the camera, guys. More depth to the stones, and I have this pattern is made from large stones, short stones, and different ones, but they are very similar. This is the profile of the vertical pole modeled, etc. And the horizontal, this one is with the technique you have just seen yesterday, but for you it's just some minutes ago you have seen it. I added some texture on the arc there, some texture. Here it isn't possible to add some texture like it was because um, it's too much flat. The texture here, it is done by the 3D printing, okay? Even the texture on top of here. The pattern here, it is 1 by 1 here. Voluntarily I modified it by 2 by 2, so you have a difference, but the shape, everything, the length, the height, it came out exactly the same, guys, okay? So here 12 centimeters, here you have 12 centimeters. Here you don't have anything, no pattern, no texture, nothing, because I will have road here too, so these will be hidden, and the junction between them will be hidden with some, I don't know, with some filler, etc. So a little difference between them, but guys, it is normal working with styrofoam that it is, the walls are more flat. Both will need some black wash, okay? Obviously, then I will start painting them. The time will be equivalent. I will not show you the painting. I will use the watch, the stopwatch to sorry, to calculate how long it would take to paint it, and it will be similar because the dimension is and the equivalent, okay? And I will use the same technique, multiple shades of gray. Then I will go from dark to bright, okay? Metal painting, black metal painting for the handrails for both, okay? Let me start making some black wash. So I don't want to make a mess here, so I prepared some paper here, and I will start the stopwatch. Go ahead, okay. Then I will prepare some black wash. There isn't a precise recipe for the black wash. I will generally go by the feeling, okay? It is black acrylic paint and water. Maybe like that. No salt, no pepper, no basilic, anything more than water and black acrylic paint. I will mix it. Maybe it is better if I take the phone and I place it a little far away, because black washing makes everything a mess. Like that. I will start with this. Obviously I will not black paint the handrails. Let me see. Yes, like that. It is just for the grooves, guys, and it is quickly done. I should have started. So instead of 30 seconds, I had to do 30 seconds, then wait for the first layer to dry, then the second layer. Totally 1 minute instead of 30 seconds for this bridge here, the digital bridge. It took me 30 seconds with the airbrush. Okay, I think I will stop here. I will wait this to dry. Okay, it is a mess, always a mess, the black wash. Nope, guys, it's not CU because I forgot the analog. Oops, the analog for BW black wash. It took 5 minutes 0 hours, 5 minutes, and let's say 30 seconds. Okay, like that. Okay, and what else, guys? What else? Nothing else, guys. Okay, digital. One 5 minutes 30 seconds, 0 hours 5 minutes 30 seconds for the black wash. Okay, like that. See you. Guess what, guys? Both versions of the bridge are finished, painted, ended. It is finally time to show you the result, guys. From the top, this is the analog bridge. This is the digital bridge. I hope on black you can see. No, guys, let me add some white. Maybe it is better on some white like this. This is the analog bridge. This is the digital bridge, guys. Both the same dimensions. I can join them together like that. Okay, and the same length, 24 centimeters, the same 8. Then also from a side view like this, guys, you can see both bridges. This one is little heavier on the top. I need to get it like that, but from the side you can see the two bridges like that. Let me start from the analog bridge and let me analyze closer to the camera, maybe like that. So primed, and you have seen both the bridges primed, then 3 layers of gray after the black wash that you have also seen on camera. Dark gray, medium gray, and light gray. Then I added also some light blue. I can show you which light blue. This one, very light blue to the mix of light gray. And I always use only 3 colors for. I start with the pure gray, then I will go a little of white, then the second lighter gray, some more white on top of it. Then I added the final result, some blue, and also some of these sienna brown for some zones like here and there. You can see that you have also brown, and some green on the bottom here, some green, etc. Very irregularly painted here and there. Here not painted very quickly because I needed just to cover the white, etc. And the other side, they are different one side from the other, like real walls need to be. The stones are flat in this case, and you see here some more brown, some scratched stones there. Here I have the arc, and under the bridge some more green, because there is some more moss where the sun doesn't get. On top of it, same thing, 3 layers of gray after the black wash. Then the last mix with the light blue there, it is called this one sky blue light, but it is too light as to be a skylight. And then a little of green and brown, but minimum part. The rails, the end rails are painted with metallic gray, and then I added some rust effect, not using acrylic but using this paint here that is rust texture, and in this case it is medium oxide, not light oxide that is the starting of the oxidation of the rust, and before it gets too dark it is medium. And inside you can see, if you want the color of this one, it is very medium rust, okay, like that. And I used this mixture here to get the metal aged with some rust. Once again, dry brush. Everything is done with dry brush except for the metal on the end rail, but everything dry brush very quickly here and there. The road too, and the clear difference are the way of making the end rails here. Okay, the railings are different because of the model. This has been modeled and 3D printed in one single piece. This not. And here don't need to add anything because it will be hidden if used. I still have to decide if I use the analog on the digital. But carving the styrofoam makes the stones too flat for me, okay? But not bad the result here. And the final touch, it is the vertical white as simulating the winter, the ice. Everything else is painted always horizontally. I never go vertical for any of my painting, but you have seen me painting many times everything. And just the final touch vertically, it adds deepness to the painting, having vertical for the ice, and use white to add some light only if you are in winter, but it add lights. The digital bridge, so modeled, you have seen me placing at the very beginning the patterns, the irregular stones, two different patterns for the road and for the walls, and the third pattern here for the arc, okay? So 3D printed, 17 hours to do but I don't calculate it to make it, because those 17 hours, during those 17 hours, I was doing something else. It is not time that I've consumed to create this bridge. Here, the side it is the same, and it is the same with more green there. The same layers of gray here, but it is a different result because here it is completely flat. Here no, the stones with this pattern are have different height even on this single stone here. These single stone here have different deepness along his length. Sorry for that. And so it makes different shades of colors, even along one single stone. Here it tends to be more same color, same effect all along the same stone and there. Here the stones are for having it so quickly made. Each stones have the same dimension, 1 centimeter by 2 centimeters. Here with the pattern applied with the ZBrush, you have different size of stones. Maybe this pattern is too little for the road, 1 by 1 centimeters. This is more adapted, so maybe a mix between the two. So this for the wall and this for the road would have been better, but who knows. Anyway, the important in plain view will always be the wall, never the road, because the cameras will always roll on the side there. Even in this case, the painting layers are different from one side and the other. Look at these. So 1, 2, 3, this stone here, 3 from the left, 1, 2, 3, 1, 2, 3, 3 from the left, this stone here, and this stone here, the second from the top. They are different, they have different patterns, and even the stones, they aren't in the same position. Here it starts with half a stone, here it starts with the full stone, so it is more irregular. Here, due to my design, but with the scratching, the stones are different. And here the railing is composed by copper rod vertically, cotton balls there, and then bamboo skewers for the smaller pieces, as you have seen. Here it is one single piece, everything is printed in one single piece, printed without supports, and it has been the difficulty of generating this model. It can be printed without supports. Okay, not on the back. You have seen me cleaning it, and it has some supports here, maybe a little there, but minimum supports possible. But I've shown you how to clean it right after having it out from the 3D printer. Okay, what else, guys? Nothing. Even here, the rust effect on the, I don't know if you can see it correctly, but the rust effect on the railings you have there, and the colors are mixed there, like that. Those are my bridges, guys. The analog and the digital. The analog and the digital. Okay? Because in life there are bridges and bridges. But now, guys, before ending this mini tutorial, I still need to show you the time. This is what you have seen me doing all along for the analog bridge and the digital bridge. Let's repeat, adding this that has been made from the starting point. So during the sketching, the analog took 20 minutes, so 0 hours, 20 minutes and 0 seconds. The digital took 20 minutes, then 25 for the pattern, so 0 hour, 45 minutes, 0 seconds for the sketching idea. Okay? Then it is where it makes the difference. For building, assembling, creating the pattern for the analog bridge, it took me first step 1 hour, 16 minutes, 42 seconds. Then another 1 hour, 43 minutes and 8 seconds. Okay, then another for step 3, 2 hours, 1 minute, 14 seconds, and this is the railing, the railing step. Then for each 0 hours, 05 minutes, 30 seconds for the black wash, 30 seconds. And here on the digital, not the 17 hours for the 3D printing. And the black wash. The total painting, they are similar, same dimension, same technique. It took me 1 hour and 15 minutes for the analog bridge and 1 hour 15 minutes for the digital bridge. Okay. Okay, guys, the same. They are the same. I use the same technique, the same. Look, it is a perfect circle down there. I used the same technique, the same pattern, finishing exactly the same way, having the same batches. I started with the dark gray everything analog, dark gray everything digital, then lighter gray for both, then final very light gray for both, then blue, then green, then sienna brown. Finally the last step was painting with the metal the railings and adding the rust, final touch. So digital, for completing it, it took 30 seconds. 45 and 5, it's 1 hour 5 minutes. So 5 minutes, 1 hour plus 1 hour, 2 hour 5 minutes, 30 seconds, because 45 minutes plus 15 equals 1 hour. 1 hour becomes 2 hours, it rests 5 minutes. Here it is a little more complicated. 50 seconds, 64 seconds, I had 1 minute, I kept 4 seconds, so 50, 64, 4 seconds, 1 minute, 34 seconds, 34 seconds, 21 minutes, 21, 37 minutes, 40 minutes, 80 minutes. 80 minutes is 1 hour and 20. So this is 21, 26, 36, 21, 37, 40, 80. So 20 minutes, 1 hour more. 20 minutes, 21, 26, 36, 41 minutes. 1 hour, 2 hour, 3 hour, 5 hour, 6 hour. So guys, here it is minutes and clocks and ticking clocks doesn't lie. We make the calculation 50, 64, 4 seconds, 1 hour, 34 seconds, 1 minute. 21, 31, 37, 40, 80, 80. So 1 hour, 20 minutes, 21, 26, 36, 41, plus 1, 2, 3, 5, 6. 6 hour, 41, 34 against 2 hour, 5 minutes. Here it is almost 7 hours. Here it is 2 hours. So there are, let's say, almost 5 hours of difference. Okay, so on a total of 6 hours to complete it, just 2, it is a little less than a third for having this. So I could have spent 4 almost 5 hours doing something else. Time consuming the analog bridge standard method, old school methods. And I don't know, guys, but this pattern here for the wall with the standard technique, I think would have been impossible to achieve. Once again, in life, there are bridges and bridges.